Hello everyone, in this video we're going to explore topic 7.3 and 7.4 slope fields. In later lesson, we will learn ways to solve a differential equation analytically. However, doing so can be difficult or sometimes impossible. A practical approach to solve a differential equation is by creating slope fields, which show the general shape of all solutions to a differential equation. Consider a differential equation y prime equals capital F of sy in terms of s and y for every point s and y in its domain. Y prime determines the slope of the solution function at that point. If you draw a short line segment with the slope indicated at each point on the y prime slope field or direction field, will show the general shape of all solution functions to that differential equation. Now let's take a look at example number 1. Consider the following differential equation: dy over ds equals negative s over 2y. Sketch a slope field of the differential equation on the coordinate plane. Alright, so this one is the y, this one is the s, right? Now, in order to do this one, you need to sketch a T-shape, right? Now, remember, we have the Christmas tree trick. Alright, if the tangent lines go in this way, the slope is positive. If the tangent lines go in this way, the slope is negative. If the tangent line is horizontal, the slope is 0. If the tangent line is vertical, the slope is undefined. Now for this line, the bigger slope, the steeper tangent line. Now for this one, the smaller slope, the steeper tangent line. Now we're going to start from this point. S equals negative 2, y equals 2. Then we substitute over here. Alright, so dy over ds equals 1/2. Right? So does that mean rise equals 1, run equals 2, right? So you go up by 1. Go to the right by 2, right? So you're going to connect this guy and this guy. So the tangent line should be something like this. Now, right at this point, s equals negative 1, y equals 2. It's going to be 1 over 4, right? 1 over 4 is less than 1/2, so it's going to be less steep, right? So does that mean you need to go up by 1? Go to the right by 4, 1, 2, 3, and 4 right here. So if you connect this guy and this guy, so it's going to be something like this. For this one right here, s equals 0, y equals 2. It's going to be 0. Now you look at the Christmas tree trick right here. It should be horizontal, so it could be like this. Alright, now s equals 1, y equals 2. Substitute over here, it's going to be negative 1 over 4, right? And s equals 2, y equals 2. It should be negative 1/2, right? Now negative 1/2 is less than negative 1/4, right? So right here it's going to be steeper, and it's going to be less steep right here. So based on my instruction, go ahead, pause the video and finish the rest. Alright, so here's the complete slope field of the differential equation. Alright, right at these points right here, the derivative is undefined. Why? Because y equals 0, right? So when you substitute over here, it's going to be undefined, right? So whenever the denominator of the differential equation equals 0, we're not going to draw a slope segment. This is because the derivative is not defined at those points. we cannot necessarily guarantee why the derivative is undefined. Right. B. Sketch a possible solution curve to the differential equation that passes through point 0 and 1. So 0 and 1 is right here, right? On the coordinate plane to the right. If we let s equals -1 and y equals 1/2, right? So we substitute over here. Does that mean we get 1 over 1, which is 1, right? So in order to draw a slope field right here, we need to go up by 1, go to the right by 1. So you're gonna get something like this, right? Similarly, if you have a point right here, s equals -1/2, you substitute over here, you have 1/2 over y equals, right here it could be 3/4, right? So substitute over here, you have 2 times 3/4. So it's going to be 1/2 over 3/2, right? So it's going to be 1/3, right? Now 1/3 is less than 1, so it could be less deep, so it could be something like this, right? So if you keep doing like that, you will have a possible solution curve to the differential equation, something like this. And the right hand side should be something like this. Alright, now let's move on to example number 2. Shown to the right is a slope field for which of the following differential equation. Again, you're going to use the Christmas tree trick. Alright, if you see the tangent line like this, the slope is positive. If you see the tangent line like this, the slope is negative. Remember, the bigger slope, the steeper. Remember, the smaller slope, the steeper. If the tangent lines going this way, the slope is 0. Tangent lines going this way, the slope is undefined. Keep that in mind. Alright. Now, here's a trick when you do the multiple choice questions. Pick a point with the 0 slope or undefined slope, right? So, right here, I'm going to pick this guy right here. Sit and sit, right? So, s and y equals sit, comma, sit, right? I substitute over here, and I know that this guy is horizontal line, right? So then the slope must be equal to 0, right? Now substitute over here, I get 12. I'm gonna eliminate this one, right? Substitute over here, it's gonna be 0, so this one could be right. Substitute over here, it's gonna be 0, this one could be right. Substitute over here, it's gonna be sit, right? So this one eliminated, right? Now I only have 2 left right here, right? So I'm gonna pick the next guy right here. Alright, so s equals 5, y equals 6, right? So then the slope is positive, right? Because it's going to be right here, right? S equals 5, y equals 6, it's going to be -1. The slope is negative, it's go over here. So this one is wrong, right? S equals 5, y equals 6, the slope is 1, which is right here, right? So the answer must be C. Now let's move on to example number 3. The graph to the right shows a slope field for the function y equals f of s. If the initial condition is 0, 6, what is the range of the solution curves y equals f of s for s greater than or equal to 0, right? Alright, now you're going to start from the initial condition. It's going to be 0, 6. So you have the point 0, 6 right here, right? So in order to get a slope field, you need to follow the flow. Alright, so you see that the flow is going to be something like this. Alright, observe that the domain should be s greater than or equal to 0, right? So you need to eliminate anything less than 0, right? Less than 0, which means on the left of the y-axis, right? So I need to eliminate this guy right here, right? So finally, your slope field graph should be like this. Now let's move on to example number 4. What is the general solution to the differential equation that generated the slope field to the right? Alright. Now, in order to do this question, you need to examine the graph of the slope field right here, and you need to follow the flows. Alright. Now, the best thing for you to do is to start from the origin, and you see that it's gonna pass the origin right here, right? And you know that the trigonometric function that passes the origin is the sine function, right? The cosine function starts from the maximum or the minimum, right? So you need to eliminate A, B, and C, right? You only have D, E left, right? And you know that the sine function is going to be something like this, right? Or y equal negative sine function is going to be something like this. Alright, so you look at this one, we just follow the flow. So it could be something like this. Alright, so the answer must be E. Now, example number 5, consider the differential equation dy over ds equals s squared times y minus 1. Describe all points in the xy plane for which the slope fields are positive, right? Now, in order to get the slope field to be positive, does that mean we get this one greater than 0, right? So, s squared times y minus 1 must be greater than 0. Now, you have two different cases. S squared greater than 0 and y minus 1 greater than 0, right? Or s squared less than 0 and y minus 1 less than 0, right? But this one is impossible. Why? Because s squared cannot be less than 0, right? So we need to eliminate this case, right? Now we're gonna focus on this one. S squared always greater than 0 except at s equals 0, right? So you need to write right here except s not equal to 0, right? Because s equals 0, when you square it, could be 0, right? So this one is not a solution, right? Now to solve this one, does that mean you need to add 1 both sides, right? So you have y greater than 1, right? So you need to answer the question, all points in the xy plane for which the slopes are positive are s and y, where s not equal to 0 and y must be greater than 1, right? And it's your time to stop. Thank you for watching. I hope you enjoyed the video. Remember that if you failing to prepare, you're preparing to fail.
We rise like tall buildings as the chemicals, they take us higher. The night's young and it's just begun as she puts her hand in mine.